Hello, everyone, and welcome to our webinar, Building Fraud Detection Apps with OpenAI. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We do 2 per week, demoing data and AI use cases and new tools and technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback about these sessions or hear ideas on topics that you'd like to see covered in our future sessions. Speaking of future sessions, we have 2 great webinars that are coming up just in the next few days. On Friday, we're going to be presenting how to migrate from PlanetScale to SingleStore free tier in 5 minutes. If you've been paying attention to the news, you will have heard that PlanetScale is eliminating their free hobby tier on April 8th. So we'd love to have you come join us to hear how you can easily transfer over to SingleStore's free tier in just minutes. We put the link on that slide, the QR code. You can take a photo or a screenshot. I'll put that link in the chat in a minute. We'd love to see you there on Friday if you're a PlanetScale user. And then on Monday, we're going to be presenting another webinar called Building Applications with Vector Databases. You can come join us to learn about the basics of vector databases, why they are so critical for AI applications. We've got a live demo and code share, little discussion of the various vector database options out there, how they compare and contrast. So if any of this sounds interesting to you, we'd love to see you on Monday. There is the short link. You can register there to grab your seat. I'll put that in the chat as well in a minute, or just take a photo or screenshot of that QR code to register and get your spot. Back to today's topic. We'd love for you to participate in the discussion throughout the session. There's a Q&A button at the bottom of your console. We have an internal mission statement to answer 100% of the audience questions that come in. That has gotten harder and harder over time as Akmal's sessions have grown in popularity. We have over 2,000 registrants today. But again, we promise to answer 100% of the questions, even if that means following up with some folks via email afterwards. Just include your name and email address when you ask the questions. We will not be answering any anonymous questions. And we'd love for you to try out the technology that we're going to be talking about. In fact, anyone who tries it today will be entered for a chance to win brand new AirPods Pros. All you'll need to do to participate in today's raffle is visit that link. It's the short link that says Fraud Detection Raffle at the end. Just visit that link, log in, and you'll be entered for the chance to win. You may know that SingleStore has had a free trial for many years now, but just in the past few weeks, we've also announced a new completely free shared tier, which we will talk about a little more later on today. And so give it a shot. Maybe you'll win the AirPods. One more thing I'll mention, we just got approval to start trying out prizes with the new Meta Ray-Bans, the smart glasses. So look forward to those in our upcoming sessions. I think we'll have those in time for the Friday webinar and the next week's webinar. So we'll probably do some mixing up. Sometimes we'll give out AirPods, sometimes the new Meta smart glasses. But anyways, exciting things happening here in our prize department. Let me introduce our speaker. Akmal Chowdhury is a senior technical evangelist at SingleStore. You may recognize him. He is a prolific author and regular speaker at our weekly webinars on data and AI. I highly recommend you search out his Medium blog. He's got some awesome demos and blog posts on there. Excited to have him here today. Akmal, welcome. The floor is yours.
Great. Well, thank you very much, Matt. And thank you all for joining. And if you joined a couple of days ago, you'll know there's a slight time change. Okay. So normally I do these events at 6 p.m. my time here in London. It's now 5, I think. So it's daylight savings, changes. In the UK, our clocks change on the last Sunday of October and the last Sunday of March. So we have a little bit of time before we get back to some kind of, in quotes, normality. I see there's already a few questions in the Q&A, and I apologize that I have to present, so I'm going to have to leave it to Matt to pick those up for now, and hopefully we'll have time to cover those as well. So again, thank you for that. And in terms of slides, well, I don't have too many. I've got a notebook, and Matt will share the link for that a little bit later on as well. So you'll be able to run this for yourself. And the nice thing that I've been able to do today is the notebook is entirely self-contained in the sense that the only thing you need is an OpenAI key. And the rest of it should just work without having to do much else. So just make your lives a little bit easier. All right, so let's say a little bit about SingleStore then. I saw the question actually in the Aviro was asking, I think you're specifically inquiring about the product and maybe less about the company, although the two are obviously intimately tied. But this is kind of nice. I mean, I usually show a couple of slides, but this one is a new one, which I thought was kind of caught my attention. I thought just give you a sense of where we started. Well, way back in 2011, okay? Although it feels very much like still working for a startup in terms of the pace at which innovation happens and how fast things sort of tend to move. And over that time, a lot of things have been added. And the key thing here is that although vectors are the kind of hot topic and necessary, for working with these large language models, unless you're using things like autoencoders, for example, then the product has had vector support actually since 2017. Okay, so we are not kind of newbies. We've been doing this stuff for a while, although it's got better in the recent past. Okay, and so there we go. So as a company, obviously, we've grown significantly in terms of number of customers, especially since this kind of break point here, roughly, sort of between 2019, 2020, really started to see phenomenal growth there in terms of customers. And we are now a 100 million plus annual recurring revenue ARR company, looking towards the next big challenge, I guess, which would be $1 billion. So there we go. Briefly then, so it is a database system. That's where it started. So in memory, MemSQL, as it used to be called, and we added analytics capabilities through columnar storage. Okay, so running these operations at scale. And so the product does both of these things through this concept called universal storage. Okay, so the ability to store both OLTP and OLAP data using the same table. And it's optimized to deal with both of those requirements. And that's pretty unique. I mean, you can achieve similar results by using multiple products. But as far as I know, we are still the only one that does this in this way. Other vendors have made some announcements as well in the recent past, but we are kind of waiting for them to deliver on their marketing. So other things worth pointing out. So we've covered Kafka quite a lot. One of my colleagues actually did a session on that not so long ago. Today, I'm going to look a little bit at Spark. That's something that Matt and I actually covered about a year ago. This very presentation we did roughly a year ago. And I'll give you my kind of updates on this and, what things have changed and what hasn't changed. And other places that you can bulk load from, S3, Hadoop, HDFS. And I think what the animation here is meant to show is this kind of ingest in parallel. So at scale, you can get data from these various sources, be able to ingest them into SingleStore. We run on the three main cloud platforms in the Western world. Okay, so AWS, Google Cloud, Microsoft Azure, and today I'm very much going to be using AWS. You can run on-prem, and momentarily when I get to the demos, I'll show you where you can access once you've created an account and got onto the portal. It's very easy. There is on the left-hand side a navigation pane, and right at the bottom there is a link that gives you access to a license. And that license you can use to install a 4-node version free of charge wherever you want. So that could be on-prem, could be in the cloud somewhere, and that is a fully featured product. It's not limited or constrained in any way. The only limitation is that you're only allowed 4 nodes, okay? I mean, but that is perfectly adequate for a lot of applications, which some of our customers are actually using right now. There's a Docker container as well. But the quickest and easiest way is to follow that link that Matt has shared, create an account, which you can do literally in less than a minute, And then once you've logged into the portal, it's very, very easy. Everything is browser-based. There's nothing to install locally, and you'll be up and running very, very fast indeed. And I'll show you some of the things today. So it stores relational data, obviously, okay? But as you can see, there's other things as well, which we've covered in the past: geospatial, time series. There's key value as well, full text search. Okay, so that's the Lucene full text search engine, which is great because what you can do now, people talk about vectors and embeddings and semantic search. Well, you can combine that with full text search. Okay, looking for keywords, for example. And that's, again, fairly unique in the industry in that, we offer this ability for you to be able to do both of them at the same time and combine them. Okay, there may be some queries that are more suitable for one type of question, other queries more suited to a different sort of approach. Vectors, obviously, I mentioned that a few moments ago. Oops, just trying to be a bit too clever there. There we go. We've talked about that. And then just to wrap it up, really, things like real-time decisions, AI apps, dashboards. I'll show you that momentarily in the portal. Ad hoc queries you can run using SQL, and there's plenty of machine learning that you can do as well. Okay, so some of the techniques, and this is not an exhaustive list by any means, okay? These are just some examples of how you can work with SingleStore if you want to do some type of machine learning. Spark is what we're going to look at today as one of the technologies. I'll also be looking at scikit-learn, okay? So that's with the notebook environment. We are looking at OpenAI, and that was really one of the reasons for kind of evaluating it against other technologies. So I was kind of interested about a year ago to see, there is all this interest around OpenAI and these, ChatGPT and GPT and large language models. How useful would something like this be if I had a problem, say like fraud detection, for example? Would this technology be useful for me? Could it help me in any way? And at that time, about a year ago, my conclusion was no, it didn't really help me very much. Simply because I think I was asking the wrong question or trying to use the technology for something it was not really designed for. It's great if you've got text, if you've got like email messages, documents, something for it to, get its teeth into, be able to analyze and be able to return some results for you. If you're dealing with the sort of data that I've been using in terms of fraud detection, it doesn't really help very much. Okay, and again, we'll look at that momentarily. Other things, there are other ways that you can do vectors, in terms of the Euclidean distance dot product. These are supported directly in the product. We have a vector data type as well that was introduced at the start of the year. And something, again, which is pretty cool for us, we have this code engine using WebAssembly, and I've demonstrated that in the past. So essentially what you can do is you can extend the capabilities of the core engine now with your own code. And that code runs in a protected environment, okay? So even if that code is bad, it does not bring your entire system crashing down, okay? It is lives in a separate space by itself, and that protects the database engine and the other resources as well. But that's a great way to really extend the database capabilities with something that maybe only you want to do, okay? And you write the code, and you can now do that. Okay. Other things to mention briefly, then this compute service that's in the pipeline. So we're going to look at this notebooks today. We'll use that, okay? We have this CPU, okay, for processing compute. That's been available since a long time. What's new is what's mentioned at the top here, okay? The support for GPU. That's coming soon as well, all right? And that's something we have planned. And then other things as well that are kind of interesting. You may be working with some of these large language models and, maybe things like Hugging Face, OpenAI, which we're going to use today, but we are looking at ways to where we can actually host these as well, in the sense that we run these in our environment for you. You don't have to install them as libraries separately, okay? There are things that we are looking at to improve your ability to be productive and without having to worry about these. And one of the concerns that we often see, and one of the questions that pops up regularly for our webinars is, what happens if I want to send confidential data out of my environment to some third-party provider for them to evaluate. And if you're talking about OpenAI, for example, I believe their policy is that they do not retain your data. You need to give them specific permission to do so, otherwise they will not do that. But still, these things are concerning for a lot of people. I talked about WASM, but we are looking at Python UDFs as well. Okay, that could be very useful too. A bit of a challenge there in terms of dealing with these kind of dynamic type of languages. So basically, what do you get? Well, you get the ability to prototype with notebooks. Awesome way to, they are very forgiving. You can make mistakes and it's easy. Go back, try the code, get it running again. We have a kind of a cron job facility as well, if you like. If you want to schedule notebooks and run them at certain times to be able to perform tasks, that is actually one of our most popular features at the moment. And then this ability to have GPUs and CPUs as well on your workload, which is the third point over here. That's coming too, okay? So lots of useful things in the pipeline for developers in particular. And then there's a whole load of other integration tools as well that we provide. Okay, so we've talked about streams in the past. That's a great way to get massive data in. CDC, okay, so if you're working with other products on the market, so things like MongoDB, for example, and MySQL we support right now. Postgres, I think, is something that's in the pipeline as well, so look for that. ETL from other database providers, and then looking at ways to get the data out as well from SingleStore into some of these other environments as well, and support for things like Apache Iceberg, okay, which is something that is coming soon as well. Okay, so lots of cool stuff, as you can see, that's coming there. All right, now, that's all I wanted to do in terms of the slides, although I've got a couple more just after the demos. Okay, so at this point in time, let me stop that. Let me blow up my browser. There we go. Hopefully you can see that okay. And let me switch to the portal here. And again, Matt, please let me know, sir, if I'm talking and it looks like you can't see what I'm talking about. Okay, I don't want to be discussing stuff and no one understands where I'm actually pointing. So the link that Matt provided for you, if you sign up, this is the portal. This is kind of generally what it will look like as you log into your web-based account. So as you can see on the left-hand side, you've got all these kind of little navigation things to help you. Okay. One of the things, I mentioned this a few moments ago, and bear with me, let me just get rid of my zoom controls so I can see at the bottom here. And so can you see right down at the bottom here, this happens to be this particular organization that I'm a part of, okay? And then one of the things that you get down at the bottom here is this thing called self-managed licenses. There we are. Obviously, I won't click on that for obvious reasons, but that's where you get that license that I was talking about if you really want to install your own 4-node version free of charge. Okay, there we go. And then you've got another sort of set of cool things. So another very useful thing on the left-hand side here, let me just use my arrow and then I'll blow up the text. Okay, is this thing called gallery. So if we click on this, okay, it will give you access to a lot of these notebooks, and they cover a wide range of different things. So even just getting started with notebooks. But what I wanted to draw your attention to, and see if I can find it quickly, is there is one on, let's have a look, threat detection it's called. There are three parts, okay? So this is the first part here. I see it, okay, here. There's part 1, there's part 2, and part 3 is over here, this one. Okay, so remember, these are notebooks. I can just click on these, it will load them in, but I'll choose not to for the moment, okay? So part 3 is actually interesting because it is, in a sense, kind of very closely related to what the problem that I'm trying to solve. But that is specifically for threat detection. What I'm trying to look at is fraud detection, okay? So they're not dissimilar in many ways. But that is something that is like a Kafka feed of data that's arriving from logs. And these are logs recording access to websites, for example. So you might see the suspicious behavior. You might see people trying to, do brute force attacks, SQL injections, these kind of things. And what it's trying to do is evaluate in real time what these, events are. If they are suspicious, alert you, take some action, try and block, whatever, or you could automate that process as well. And so that's a very useful one that could have some bearing on what we're trying to do today as well. All right. Okay, now let me just pull this one down again. And again, just keep an eye on the time. So make sure we are running well. Okay, that's fine. So what I'll do is I'll show you the notebook. Now, notebooks here, can you see on the left-hand side, one of the links that you have, just the notebooks. Okay, let me just, again, blow that up for you. There we go. And then there's sort of personal and shared. I've got one that I've created here. And specifically, when Matt shares the link for the one that we have for this one today, you'll see that in the top right-hand side, we have this button here called New Notebooks. And if you click on that, it gives you the option to import from file, okay? So that's what you would need to do in order to bring that into this environment. You will need to have some workspace resources running as well. And the way to do that is here. You can see this thing here called Group, okay? So just click on this, and it will present you with a couple of options. So you can see the free tier, the starter one, workspace, okay? That is good for sort of small scale use cases. There are some limitations in terms of storage. It's 1 GB of compressed data, 1 database, 10 tables. There's some other limitations as well. But equally, you can use the standard one here if you wish. And that gives you a lot more choice in terms of configuration as well as cloud provider, okay? So the starter one currently runs on AWS. I think there are plans to introduce other options there as well. But again, let's move on to the main part of today's presentation, okay? So this is a notebook. I've run this a little bit earlier, okay? Simply for time, as Matt will tell you, I talk too much, so we'll walk through this, okay? And I'll tell you what my overall mission was and my goal was, and what I was able to achieve with OpenAI. So originally, this kind of started off as a kind of a thought experiment, okay? And it was, like I said, GPT getting a lot of airtime. Could AI be used just beyond chat? That was my kind of thinking. And one reason that I happen to pick specifically for fraud detection here is that I had actually been a victim of fraud several times actually in the past. Despite however careful I am, my credit cards in the past on several occasions, and there's one that I had which I kept for emergencies and never used. Still, someone was able to discover the number, use it on a famous e-commerce website. I won't name them, okay? But they were good because they acted very promptly. And the card was used to purchase some items. And they were sort of small value items. You're talking about like £10, £15, £20, and a few of those, okay? Just so it wouldn't look too suspicious. The thing is, it was suspicious because I never used that card. Therefore, I was able to spot this straight away. And therefore, I was kind of curious to see, okay, here is a problem. And then because I've been a victim of fraud, would I be able to, take some existing technology? How would it handle this type of problem? And the other thing I wanted to do was to say, well, okay, in addition to looking at, say, something like GPT and, OpenAI and related technologies, how would existing machine learning, technologies work? For example, if I were to use something like scikit-learn, for example, or Apache Spark, which has machine learning libraries, would these be better? Would they be worse? Would they be the same? What sort of results would I achieve? Have something to compare against. And that was my thinking. And then I came across this wonderful quote here. This is from an article. Now, apologies, the text is a little bit messed up there, but I'll read this out to you. It says, building AI models from scratch is difficult and time-consuming. But with GPT-3, even a 10-year child can create well-performing deep learning models. So this is from a blog post. And I've got the link there if you want to follow that. And I thought to myself, well, okay, well, I'm not 10 years old, but challenge accepted, okay? I'll have a go at this and see, would I be able to utilize this technology despite not being a 10-year-old child? So the specific fraud data set that I selected, it's available on Kaggle, okay? I mean, if you have access to something else, by all means, utilize that instead. If you've got something better, that's great. trying to find public domain data sets can be a challenge. And there weren't too many in terms of the choice for this that I had, but I did come across one very famous one, which was looking at credit card transactions that occurred over a period of time. That was in September 2013, and it was for 2 days. And it was a total of nearly 300,000 transactions. And of those, only about 500 were actually fraudulent. And that it represents just 0.172% of the total. So you can see already that it's a very imbalanced data set. And there's plenty of content and articles out there on the market that describe what to do in terms of dealing with, these kind of imbalanced data sets. And I've got a link to one of these here. This is by Jason Brownlee. Awesome guy, knows his stuff, publishes regularly. And, he's got a website with lots and lots of content focusing around machine learning. So we've got a couple of fields. We've got a time field, which is just the number of seconds elapsed between a transaction and the first transaction in the data set. There are columns labeled V1 to V28. We are not told what these are, what these represent for confidentiality reasons. We do know the monetary amount, how much, is the actual value of the transaction. We can see that. And then we have a class to tell us, and that's the response variable, That tells us 0, it's no fraud, or 1, whether it is a fraud. So what I did to prepare that, and if you download this from Kaggle, it is actually pretty big. It's about nearly 150 megabytes in size. Now, the thing is, that's quite a challenge in terms of how to process that on tokens and OpenAI. I'm going to probably run up a big bill if I use that entire data set. And then it's probably not going to help very much, given the fact that we have a very skewed data set as well. So what I did was I took a smaller sample. There are a variety of ways you could deal with this. And if you are a data scientist, you will know some of these techniques anyway. So a simple technique is just to say, okay, given the fact that the fraudulent transactions are so small anyway in number, let's keep all of them. And then let's select a small number of the non-fraudulent transactions. And so that's what I did. So I picked a certain percentage of those, and I used Spark to be able to separate that out. And in the end, I've got a total of much smaller, 3,265 rows, which is what I'm using here for this particular analysis. And then the things that I'm trying to measure in terms of the metrics, as you can see from the chart there, is accuracy, precision, recall, and the F1 score, So that's what I'm trying to do. And these are the numbers that we're going to utilize momentarily. So what I did was simply create a database, just call it, credit card DB, just dropped it if it already exists, create it if it doesn't exist, very straightforward. And then a directory here to download the CSV file from, which actually sits on my GitHub repo. And that's what I'm doing just below here, just actually accessing that CSV file, which I've prepared the data set for you. And that's coming from my GitHub repo. We just load the data into a pandas data frame here. Just read it. We've copied it into that data directory we created just above. And then just down here, first thing I've done is when you create a database, when you create a workspace, one of the things that you need to do is create a database, obviously, to utilize it. We've just done that above. And what you need to do in order to access that from the notebook, you need to ensure that this thing up here is selected correctly. So it needs to be pointing to both the correct workspace and the database itself. So you need to set this. So in this particular case, you can see that this is a shared environment that I share with my other colleagues. So, here you can see there's some databases that they've created as well, but that just need to pick out the correct one. Now since I've run this already, that's fine. So that's all we're doing there. And then we just take the pandas data frame, we just write that into the database here using the toSQL. That's a pretty fast operation. And you can see it tells us it's written the 3265 rows into the database. And then just as a sanity check to make sure that stuff has gone in correctly, we read it back. And we read it back into a new data frame here, and then we take a look at the structure. So here you can see we've got all the columns, we've got time here, and then we've got all these fields, V1, V2, and so on, all the way to the end here. And then we've got the amount right at the end, and then the class, which tells us whether it's fraudulent or not. And so if we look at these columns, I mean, they are just kind of numeric representations. We have no idea what these actually represent for confidentiality reasons. So if you've got access to some actual fraudulent, transaction there, and they are meaningful, I would highly recommend you substitute those and try that out, okay? But obviously be careful to do so. Ensure that you have the permission to utilize that data in terms of doing this analysis, okay? That's fine. The next thing to do then, we just take a look and we just confirm that, yes, we have actually retrieved back the same number of rows that we wrote, 3265, and then we take a look at this in terms of grouping by the class just to see what is the structure. Well, we have our 492 fraudulent transactions. Remember, we're keeping all of those, and we've got 2,773 non-fraudulent transactions to make up the total 3265 in this case. Okay, and we just take a look at the entire data set there. As you can see, it's kind of just chopped it off there just to show us the beginning 5 rows and the last 5 rows there, but it tells us it's 31 columns by 3265 rows. So really, I mean, if you think about it, the only thing we can really analyze is the amount. None of those other columns are, from a human kind of perspective, if you think about it, just to have a look at the numbers, this just tells us a little bit in terms of the mean. It's pretty low. I mean, it's under $100, I think, or 100 euros probably, because I think this was done in Europe. The standard deviation, the minimum is 0, the maximum is almost 3,000. And so one great way that we can do is just simply do a plot. And this is just using Plotly. So you can see that the distribution is fairly even there. It's generally amounts under 1,000. Okay, so if we take, oops, let me just try and see if I can get my... Right, there we go. All right, so generally the amounts are kind of this sort of level. Okay. Okay, let's just zoom out. Let's just take a look. All right. I think I've messed that up. Royally, that's okay. No worries about it. I mean, you'll be able to run this. But essentially, you saw the pattern of distribution. It's pretty even. Yes, you see some outliers higher up, okay, and I'm sorry, I'm trying to get that back, but the display is gone. I will stay safe and not refresh the browser. Leave it for now, okay? Sorry about that. It's my fat fingers trying to do too much, but it's okay. Another way we could look at it is simply through a histogram. So again, this is a great way to see that generally the amounts that are in question are fairly small, okay? And that we're not really seeing anything pretty big. So after about that point there, you see there's hardly anything along the x-axis. So this kind of follows that typical pattern of what fraudsters tend to do. They'll pick small amounts simply because they'll think you're not going to notice it, right? And that's the sort of behavior that tends to be adopted. Okay, so moving on, then let me show you what I did with scikit-learn. So I thought this would be great. Just simply, it's a few lines of code. I just install it. I just use the logistic regression. Why? Because we've only got 2 outcomes. Either it's going to be a fraud or it's not going to be a fraud, right? I mean, it gives us a simple kind of determination of what we're looking for, and that's all the code there does. So I picked 30% for my test size. I've got a random state of 42, which I use throughout the code there. And then I simply do a plot there to show me what it has actually delivered in terms of result. And so if I look at this, I can see that the genuine is pretty good. It's done a good job. It's identified the vast majority of those. It's done a pretty good job on the fraudulent ones as well. It's only misclassified 4 of these genuines as fraudulent. So probably we'd annoy a few customers there. Here, it's done a bit worse there in terms of saying, well, it's fraudulent, but it's identified it as genuine instead of class, type 2 error there. So a bit worse there, but not too bad. Overall, the result there is pretty good, I would say. I mean, you know, for a few lines of code, we've done really well there. And if we look at the summary here, overall, we can see that the accuracy, the precision, the recall, the F1 score, all pretty good values there. And I didn't do any tuning whatsoever there. You know, I ran through this fairly quickly without having to do too much work. And you can see that the results overall, I would say, are pretty solid and quite good just for a sort of first iteration. Next, take a look at Apache Spark. How did Spark perform on this? And this is kind of new for us. Okay, this is something that I just recently was able to achieve, is actually getting Spark installed in our notebook environment. And it's as simple as this. Okay, and you can try this out as well when Matt shares the link to the notebook. You will see much more output than you see here. It's simply because I've run this already, and then just you get all the details of the packages that's coming down. So with Spark, again, using logistic regression, same sort of approach. Take a look at this. One thing that is interesting about Spark is that because it is a distributed system, unfortunately, the behavior tends to be a little bit unpredictable sometimes, simply because of the way Spark works. So this thing here, in terms of random split, you need to be very careful about this. I've given it some hints as to how I want to break the train and test in, and I've given it a seed, but no guarantees that I'm going to get anything back in terms of how, you know, scikit-learn behave, right? There are ways to kind of pin this, if you like, and that's kind of beyond the scope of what we're talking about today. But essentially, just the code, again, using the Spark libraries there. You can see there is just a warning about not finding Hadoop. That's okay. No worries about that. And again, the same thing here. Just do the plot here to see what sort of results we get back. And overall, we can see that Spark does really well. It's identified the vast majority of the genuine ones correctly. Only 2 misclassifications here, type 1 error. And then in terms of the fraudulent ones, it's done quite well there as well. And only misclassified 16 here, type 2 error. Now, if you're sharp-eyed, you'll see that the numbers here are not quite the same as the numbers in terms of the size. So add all these together and you won't get the same values you did with scikit-learn. It's bemusing. It is the way that Spark works, okay? You have to think about this. And again, it's beyond the scope of today's discussion. But happy to say, as you can see, both technologies seem to work well. They do a good job. This is kind of classic machine learning type, but, you know, just using existing libraries for a well-defined problem and giving it the data, and we're getting back pretty good results without too much effort. Okay, so again, in terms of accuracy, precision, recall, F1, Spark's numbers are very good as well. Okay. And then the last thing here was OpenAI then. So I'm kind of picking something that is really much more designed around semantics, text. You know, give it sentences and paragraphs and it's happy. Give it something like this where it's kind of almost black box type data. You know, it doesn't really understand what this means. How would it perform? And so what I did, again, just install it. I put my key in, okay, using the sort of get pass. I ran that already. And then one of the things that you can do is that if you don't have an account with OpenAI, you can create a free account. They used to give, I think it was like $20 US in terms of free credits. The thing is that if you are not a paying customer, these 20 credits, $20 worth of credits are, the priority of the resources is much less. So there is a little bit of a workaround to that. And so what this code does here is says, okay, if it doesn't succeed in terms of accessing the API, keep trying, okay? And so eventually, of course, it will time out, but this is a great way to still utilize this and have the code working. And then again, just prepare the data, have it ready in a format that I can send. Here, I simply create a prompt then, and then I give it a description and I give it a bit of information to say that I'm going to train, you know, use this following information I'm going to give you in a minute, train a model to classify transactions as fraudulent or not fraudulent based on their features. And then I've told it that each transaction, and I've given it a detailed description. Okay, I won't go through all of it, but you can see the text there. So essentially, I've told it that there are X number of features, what's labeled, what is not fraudulent, what is fraudulent, and then I'm telling it to use the appropriate API to classify this. If you like, this is the kind of introduction that I'm giving to the GPT. And then just subsequently, what I'm doing is just iterating through and sending these in batches to save time and resources. And it's just taking those values, the label and the features, sending them across, and then, it's returning the results, which is just sort of saving there temporarily. And the next bit there is just to say, well, okay, once you've finished, and by the way, this took about 11 minutes to complete there. As you can see, I ran this a little bit earlier today. In the past, about a year ago, when they last did this, I think it was more like 20 minutes. The cost of doing this today is also far less. You're talking in terms of cents, almost, whereas about a year ago, it cost, I think, me anywhere between $13 to $15, I think was the cost, sending this exact same data across. And then down here, I'm simply saying, well, okay, now I want you to evaluate some things that you haven't seen before. You've got a model. I'm going to give you some new data. Tell me what you think in terms of whether it's fraudulent or not. And so when we do the confusion matrix here, it actually does terribly. So, well, it's mixed. Let me put it that way. Yes, it did well for the fraudulent transactions, got the vast majority of those right. Only 2 type 2 errors here. It's, misclassified, but it did very poorly on this. I mean, it didn't really identify the vast majority of these. And I even tried to help it up here by saying, well, look, what I want you to do is, if you find, where is it? Here we are. Here's the code. So essentially, the result that I'm getting back is either going to be fraudulent or not fraudulent. If the text is fraudulent, I'm going to mark it as 1. I haven't told it specifically not fraudulent, but anything else it sends back, I've marked it as 0. I will give it the benefit of the doubt to say that it is not fraudulent, right? I'm assuming that that's what it's going to do. And even in that circumstance, you can see that the result is not good. And so disappointing, not much of an improvement since last year, pretty much the same, I would say. But again, I think that's, I'm using it for something it wasn't really designed for. So again, if we take a look at the numbers, pretty poor. And so the key thing is, what I think this technology is really helpful for is as augmentation. It's not going to be a direct replacement anytime soon that I can see. I think it's useful to analyze text, such as email messages, possibly to detect, fraudulent behavior, fraudulent activity. I think some fine-tuning could help. Finding working examples, though, is a real challenge. I mean, you really have to dig around and find the appropriate examples. I really struggled with the code for this for quite some time before I had it working. There is an AI cookbook that you can access, okay? That is on OpenAI's website. That's worth looking at in detail. And then my words of caution to you, be careful. Care with privacy and personal information, okay? If you're going to try this out for yourself, ensure that you have the appropriate privileges and permission to do so. In the most cases, I'd highly recommend start with fake or mock data. There's plenty of, Faker is a great tool that you can use to generate this type of thing as well. But if you've got genuine data, awesome, try it out and, see how well this performs. Think very carefully about the prompt design in terms of the prompt engineering. That seems to be the key skill that people need today. How to write a good prompt, describe to the large language models very precisely what it is that you want, give it examples, show it what sort of results you're looking for. And as the more descriptive you are and the more help you can give it, the more it understands in terms of the problem that you're trying to solve. But as you can see in this case, it's a real challenge for the LLM as well, because always sending across these columns that have these numeric values, and I'm kind of asking it to interpret that in a way and come to some conclusion and some assumption to give me something meaningful from that, and it's not really happening. And what's your cost to manage your budget? Fortunately, those things have really gone down. So the cost of running this now today is much, much less. I think I'm looking at roughly 10% of what it was a year ago. And so it's much, much better. Okay, so let's just get back to the slides a moment. Okay, and then I'm going to show you a couple of things. All right. So the typical way that we tend to use LLMs is this kind of way, in terms of we have got some content, right? An article, some documents, something like this, something that we use that for example, that is unique to our environment. Maybe the LLM has absolutely no knowledge of that. If it's private, then it shouldn't. But we want to be able to get some insights into that. So we teach it. We create these vectors. We store the vectors in a database system, for example. We use that to augment its knowledge, and we ask it questions on that, and we get some response back. And that helps us in terms of getting a better understanding or a summary or whatever it is that we are looking for. That's very, very useful. The problem that I think we are kind of facing today is where we've got these pipelines of data that are coming from external sources. We need to be able to perform these transformations in real time. And we can do that with SingleStore, okay, through its pipelines, through these notion of stored procedures, ingesting into the database system, and being able to process along the way as well whilst that's happening. And an actual example of that, which I mentioned a little bit earlier to you, was this real-time threat detection, which kind of follows this kind of style here. So we have these events which are benign or malicious. We create the embeddings for these on the fly, and then we are using this sort of, Confluent, as the case was, to ingest the data using pipelines, analyze that in SingleStore, look for these kind of matched attacks. So you can see that the general kind of architecture, the workflow here is very usable. We could apply this to fraud detection as well. That would work equally, I think. But it's just a question of finding where, the embedding creation phase would be useful for us. In the case of this particular set of transaction and this data set, as you can see, it's a real challenge, not very useful. But suppose we had things like emails, for example, and we teach the LLM all about fraudulent emails, give it lots and lots of examples from which you can learn. And then as the system is running live, as these events occur, perhaps an email is sent to somebody, a customer, maybe trying to entice them to click on something or to go to some website or offering them something unique, then that is something that the LLM can detect straight away and be able to say, okay, this is the threat. I need to stop this, put this to one side, maybe alert a human or take some automated action. And that could be a really, really useful way in terms of managing this and utilizing this technology for real problems. Okay, so today I am very fast. So there we go. Any questions? Matt, I think we have hello@singlestore.com as well, don't we? Not just team@singlestore.com. So,
yes, yes,
okay.
indeed. Questions,
All right.
I've just put that in the chat a minute ago.
Okay,
You can
awesome.
email any questions. Akmal will receive those. hello@singlestore.com. And yeah, we still have some open questions in a few minutes
Okay,
to
great.
get through them.
Do you want me to show these, Matt, or do you want to take the questions first?
You can, I'll get to those in a minute. So you
Okay,
can take that off
that's fine
for now.
Yeah,
But yeah,
questions,
you've gotten a couple questions in here. In the meantime, I've tried to answer as many as I can.
Okay, thank you,
Keep
sir.
those questions coming. Like I said, we're going to try to answer as many as we can. This
Yeah.
one I see from Alfred. I like to evaluate the different types of models by looking at metrics, several metrics, including the KS statistics. Do you have the KS statistics readily available for the model that you have built?
Oh, I don't. That's a great question. Thank you very much for that. So I will look into that. The notebook will be shared with you. So you're very welcome to modify the codes to your heart content. If there's some libraries or some code that you've written yourself to determine this, by all means, utilize those. And remember, if you just want to take everything that I've given you today, the only thing that you need from this, because I've even given you the data set that I've used myself, is just the OpenAI key, and that's all. I mean, if you want to go down that route, but certainly as far as scikit-learn and Spark are concerned, those will run out of the box, and you could apply those and generate those statistics, hopefully, and that will give you some better insights into the data. But thanks very much for that. I will definitely look into that. That's a great pointer.
Awesome. Okay, Rahul is asking about what kind of model were you using in your demo, and what were the parameters?
Okay, so in both cases, as far as scikit-learn and Spark were concerned, it was logistic regression, okay? So why? Because remember, we're only interested in two possible outcomes. Either it's something fraudulent or it's not fraudulent, okay? It's got a value of 0 or 1. That is what the original data contain, and that is what I'm kind of training it on, and that is the class that I'm interested in. Now, as far as OpenAI is concerned, you can see there it's a bit of a challenge. It doesn't really understand that concept. So I had to say something in terms of the prompt to say, well, look, here's what the data looks like. It's got these number of columns, and there is something that represents whether a transaction is fraudulent or not. And I'm going to give you some samples of data to look at. I want you to go away and learn this, build a model. And so it builds a model. Now, what kind of model it builds, only it knows, okay? Because it's using its own kind of training, if you like. And so that is not, it's not something obvious from the code itself, but it would probably need to dig deeper into in terms of understanding it further.
Awesome. Okay, I see a question from Jose. What measures do you take to address potential biases or limitations in ChatGPT's responses when detecting fraud?
Yeah, that's a great question. So one of the things that, and Matt will know this because we've done quite a lot of webinars where, for example, I've used LangChain. And one of the nice things about LangChain is that it gives you the ability to interface with SingleStore very easily. Instead of asking SQL queries of the data, now you can just ask queries in natural language. And there's an option where you can ask it to use verbose mode. Basically, tell me how it is that you are evaluating this query that I'm giving you in natural language. The thing is, it gives you a certain level of information, but mostly it's opaque. It doesn't give you enough detail. And this is something that we saw in a webinar that I did about loans. Going to a bank or say a financial provider of some kind and then asking them for money. Maybe you want to buy a car or a television, or you want to get a mortgage for your house. And in terms of the results that I saw there, again, it gives you and it could be just fortune, but correct answer, it figured it out. But when I asked it to explain in detail how it arrived at the answer, yes, it gave me a certain level of detail, but didn't give me further information. Now, in terms of loans, this is very important, for example, because you want to ensure that you are practicing fair lending laws, for example, right? And therefore, what is the bias? I have no idea. I can't see it because it's opaque. And so the way that these large language models are trained is there will be biases simply because of the data that they are trained on. And that may be inherent in terms of the response that I get back. I can't see it. I need to dig deeper. This is only the likes of OpenAI probably know in terms of what it is that the total sort of data that they've trained it on, for example. Okay, but they have multiple models available. It's very difficult and very challenging to kind of investigate this. Until we have better tools to kind of give us greater insight, I think this is going to be a real problem. And this is definitely something we should flag and be aware of, I think, because, again, there may be rules and laws that we have to obey to ensure that whatever we're trying to achieve is balanced and fair. But absolutely great question. I wish I had a better answer for you.
Good stuff. Akmal, we've gotten lots of questions about RAG, or retrieval augmented generation. Some of the questions are like, did you try to add context using RAG here? Some of them are broader, just like, how is SingleStore used for RAG? Do you have any webinars on this? So I wonder if you could just talk about that for a minute.
Yeah, so that's a great question, Matt. So here is an example of how you could do that. Essentially, you are taking the large language model, okay, and then you're giving it something that, and so the example I kind of used recently. So imagine you've got a large language model. It knows nothing about William Shakespeare or any of his plays. Never heard of him, right? And let's say we want it to write a play like William Shakespeare might have written. So what we need to do is we need to give it all William Shakespeare's, I think, was it 30? Roughly 30 plays, something like that. All of the plays of William Shakespeare, and say, look, here, learn from this, okay? And from that, it should be able to pick up the style of the bard, how he wrote certain things, the characters, and all of this kind of thing. And then we can ask it, look, now you know what this author, how he composes his plays, write something in his style, and it should be able to pick up and be able to do that. So it may not be perfect. I don't know. I mean, William Shakespeare is not alive, so we have no one to kind of ascertain whether it would be good. But there are experts around who may be able to comment and say, yes, you know, this is in the style of the bard. And so in these situations, typically for RAG, it's basically adding some information, typically that would be unique to us, for example, in our environment and our corporations and our enterprises that the LLM doesn't know about. Now we want to add that knowledge to it temporarily, ask it to evaluate that, maybe give you some summary of that, and so on, and so that we can do that. And so this approach is the way we do it. And then generally what you do is you create these embeddings, these vector embeddings, which you need, which are the kind of representations of the text that we are trying to evaluate, and then ask it a question. And again, that question has to be converted to a form that the LLM understands, and then it can give us meaningful results. So, yep, RAG is very easy to do. We've got lots of stuff. And then check the gallery, which I showed you a little bit earlier. Okay, so there should be some great examples there. And there's ImageNet as well, if you want to do things like pictures. That's a great way to evaluate that as well. And then more broadly, I think, you know, using something like SingleStore for storing these vectors, think about it like long-term memory, okay? Stuff that you want it to remember for a long time. Once you've spent the money creating these embeddings, you're not just going to throw them away unless it's a very, very small scale project and maybe you don't care. So you want to keep that data for the long term so you can ask queries again and again in the future. And that's the benefit that you get with using a database management system. And remember, you get all these ACID properties as well: atomicity, consistency, isolation, durability. Lots of people are going to be accessing the system at the same time. You want to ensure that you get good and consistent results over and over again.
Good stuff. Thanks, Akmal. One more that I'll pull back. I tried my best to answer these as they came in, but there was a couple questions about LLMs. You know, do you work, can you connect with different LLMs? Like,
Yes.
you know, there was questions about Llama and OpenAI and Hugging Face and Amazon. There's just lots of questions. I wonder if, I know you've done a lot of webinars on all of those. And so I wonder if you could just talk a little bit about, you know, how SingleStore can work with those, but also have you noticed any pros and cons of different LLMs for different use cases or anything like that?
Yes. So essentially, remember, the way to interface with these LLMs, generally, there's a sort of very similar approach in terms of the APIs and the language support and so on. It's very, very straightforward. We've got, I think, within Gallery, there should be something on Bedrock, which was very kindly built for us by AWS to show us how we can access some of the models that they provide in their environment. And remember, I showed this a little bit earlier on, so I just pulled this up again. So we are working on this, host and run ML plus Gen AI models, okay? And obviously, Hugging Face is a great first place to start in terms of providing this directly from our environment rather than you having to install this stuff. It might be a bit of a challenge with OpenAI, you know, because they are paying customers, okay? Not sure how we would achieve that. I don't know. I mean, that's something for the future. But, you know, there's lots of great stuff. Meta have Llama 2, okay? Mistral is a new one, which is open. So there's some great open source ones that are coming up on the market. Now, are these interchangeable? Generally not, okay? Because remember, they are trained in different ways, trained on different data, and there are some that are specific to verticals. So I've heard cases where Bloomberg, for example, have trained something specifically for their environment, and that is their use case and their customers. So you need to find, for these general purpose ones, I think far and away, OpenAI, I think, is still the one that sets the bar and the one to beat. But I would say that the open source community is catching up rapidly. We're coming up with some really good ones, and look to those as well as a way to utilize the technology without having to pay so much in terms of cost. Yes, cost in terms of processing and local install and so on, and managing the infrastructure and so on. Those things we may be able to help with some aspects of that as part of this compute service.
Awesome. Thanks, Akmal. Will you jump to those last slides? A quick note before I announce the AirPods winner. As I mentioned, Friday, we're going to be presenting how to migrate from Planet Scale to SingleStore free tier in 5 minutes. If you're a Planet Scale user, you probably know that you have 2 weeks before they're shutting off your free tier, the hobby tier. So we'd love to show you how to come on over to SingleStore's free tier. And then on Monday, we are going to be presenting building applications with vector databases. We'd love to have you there. There's a live demo and code share. I put both of those registration RSVP links in the chat. Grab your seat, and hopefully we'll see you on the Zooms either Friday or Monday or both. And then the announcement you've been waiting for. Today's AirPods goes to Anand Gupta, database manager at Apple. At Apple, you should already have Apple AirPods. Well, anyways, thanks for joining, Anand. If that's not you, don't give up. We're going to give out one more AirPods by the end of the day to someone who has tried out Akmal's demo here. I have put the GitHub into the chat. There it is. It will also be included in your email. So keep an eye on your email. Everyone will get an access to this video recording and this GitHub link again. We're going to have this publicly available in our gallery, so you can very easily access it. But there it is in the meantime. Thank you, Akmal, for an awesome session as usual. And thank you to our audience for sticking with us. See you soon. Bye, everyone.
Thank you, everyone. Bye-bye.